In this video, we're going to solve a subnetting problem. Which subnet does host 192.168.43.168 belong to? And it exists on a 255.255.255.240 subnet mask. So here we have our IP address, here we have our subnet mask. We need to figure out the subnet that it lives on. The name of the subnet is the network ID or subnet ID. It's sometimes seen as different wording there, but what we want to figure out is what's the name of the network that this particular host belongs to. So the first thing we want to do is we want to convert the subnet mask to binary. We want to convert this number to binary, and basically it's all ones up to a point, and then it switches to zeros. And the key to this is really finding out at what point are we switching from ones to zeros. So for this one, it's all ones all the way through, actually half of the fourth octet. If you convert 240 to binary, it's 11110000. If you're rusty on your decimal to binary conversion, I've got a video for that, and you should check that out. So I'm going to convert that subnet mask to binary. It looks like this. And what you'll notice here is these three octets are all ones. What that tells you right off the bat is that those all are part of the network. And that means it's not going to change. From the first host to the last host, those first three octets are always going to be the same because they're all ones. So our answer is actually 192.168.43. something. We just need to figure out what that something is. So what I like to do next is I take this and I draw a line right through the split between the networks and the hosts. This portion represents the hosts, and this represents the networks. And the next thing I can do is I can convert the IP address to binary here. But I don't really need to convert the entire address, because the only part that is actually going to change is this one right here. We've already decided 192.168.43 is the same because these are all ones. The only one you got to play around with in here is this 168. So now all I need to do is convert 168 to binary. So it's actually a little bit easier than it looks. Now you should remember that every bit in this process has a value. And when you're converting from decimal to binary, you use a chart, something like this. If you can do it in your head, even better. But in my case, I'm going to do it like this. 168. 128 fits within 168, so I'm going to mark for that, and I'm going to say 168 minus 128 equals 40. 64 doesn't fit, so that gets a 0. 32 fits, leaving me with only 8. 16 doesn't fit. 8 fits, but 8 is the rest of it, so these must all be zeros as well. This is my 168 in binary. 10101000. So I'm going to draw that out here underneath my subnet mask. 10101000. This is a host within the network. Now, something that you'll need to understand about my method is that I use a visual representation of how this works. I like to think of subnets like bookends. There's always one bookend on one side and another bookend on the other side holding the network together. And those bookends, in my case, are my network ID and my broadcast address. And everything between those bookends are my usable hosts. So I draw a chart N1LB. Network ID, first usable host, last usable host broadcast address. And this is going to help me solve for all four of those. So even though this problem is specifically asking for this piece, I can solve for all four at once. Now, something we know about the network side of an IP address is it never changes. From the first host to the last host, from the network ID to the broadcast, the network side never changes. So I'm just going to bring this down, this 1010. And if you understand this concept of bookends, you'll see that the network ID and the broadcast are the two bookends for my network. They can't be used for hosts, but they are the front and the back of my network. So the very smallest number possible is my network ID. The very smallest host I can make out of those bits is my network ID. So what's the very smallest number I can make with 4 bits? These 4 bits left here? 0, 0, 0, 0. The very smallest possible number. Now you could take that number, flip it back to decimal, and you're done. But I want to show you a little bit more. The very largest host you can make on this network is all ones. 1, 1, 1, 1. And you'll notice the network ID is always zeros in the host portion, and the broadcast is always ones in the host portion. These are going to be opposites. Now, just to be complete, let's solve for the rest of it. The first usable host on my network, the next smallest number I can make with 4 bits is 0001. And the very largest number I can make, the very last number I can make, without running into this broadcast, is 1110. You'll notice these are always opposites in that host portion as well. Now, no matter what the problem's asking for, if it's asking for the network ID, the subnet, if it's asking for the first usable, the last usable, the broadcast, if it's asking for the range between first and last, you have all the numbers right here. You simply need to convert the one you need back into decimal. So this N1LB chart demonstrates the entire range of your network. So the answer happens to be this 10100000. I'm going to convert that back to decimal. I can actually use my same chart down here. I'll just use the bottom of it. I want a 10100000. Effectively, I'm adding 128 and 32. So the answer is 160. 192.168.43.160 is the name of the subnet that host belongs to.